Watch how this 55-year-old patient walks through the clinic door. Every time that cane hits the floor, observe the heavy, unnatural mechanical strain. He is struggling to bear his own mass. His complaints are severe but highly specific. Chronic joint pain in his knees, wakes up at night suffocated, and dreads his body will collapse. While a body mass index of 37 often prompts a standard diet prescription, that approach ignores the immediate crisis. The patient is experiencing a cascading biomechanical failure. To understand what is happening inside his body, look at it as a physical structure. Right now, the building is on the verge of a critical architectural collapse. Prescribing painkillers for this level of structural distress is as ineffective as painting the facade of a collapsing building and expecting the walls to hold. If we want to resolve the joint pain, we have to address the underlying mechanical load. No chemical intervention can fix a physical structure. In human architecture, the knee joints serve as the foundational support columns. They are engineered to carry the load of the entire structure above them. Evolution designed these columns to safely support a 3-story building, but in this patient's case, they carry the weight of a 10-story high-rise. That massive, unapproved weight dictates how the joint operates. The constant excess mass physically shifts the knee's natural axis of rotation far out of its proper alignment. This diagram shows the resulting mechanics. The shifted axis creates continuous, immense pressure crushing the delicate cartilage. Over time, this downward force remains constant. With no opportunity to recover, the cartilage slowly compresses, splinters, and eventually fails completely. As long as that physical, mechanical overload exists, no chemical intervention or steroid shot can restore the crushed cartilage. The mechanical failures extend beyond the knees. The patient's second major complaint is a cycle of severe nighttime suffocation, loud snoring, and chronic daily exhaustion. The biological diagnosis here is obstructive sleep apnea. It occurs because excess fat tissue has infiltrated the space around the patient's pharynx. Think of that accumulated neck fat as a heavy physical sandbag resting dangerously close to the human airway. This cross-section shows how gravity controls the condition. While the patient is standing, the sandbag sits harmlessly to the side. But upon lying down, gravity pulls that heavy mass block directly over the windpipe, completely blocking the airflow. The blocked airflow stops oxygen from reaching the blood. This triggers a frantic neurological alarm, and the brain violently wakes the body up just to shift the sandbag back and gasp for air. The patient is locked in a nightly, losing wrestling match with gravity. A standard diet plan is entirely inadequate here. To fix these issues, the clinic prescribes a comprehensive engineering restoration plan. The primary physical objective is straightforward. We must gradually reduce the body's overall mass. Doing so will remove the sandbags from the neck and relieve the overloaded foundation columns. But this presents a cruel paradox. How can a patient burn calories through movement when their structural columns are too damaged to safely bear weight? To solve a physics problem, we use physics. The solution is aquatic therapy. This illustration shows the exact biomechanics of the treatment. By utilizing water's upward force of buoyancy to counteract gravity, we erase the heavy downward load. The patient can move and exercise their joints freely without bearing structural strain. A sustainable path forward requires a strict accounting of the body's biomechanical limits. Recovery depends on ensuring the structural load never exceeds the foundation's capacity.